I have here another substitution problem where I'm asked to change x into this variable 1/3 in this case. And the only thing that's different about this versus any other type of algebraic substitution is that it's going to be a pain in the neck dealing with 1/3 because I'm taking a fraction and I'm putting it into another fraction. So let's walk through this one step at a time. And I'll give you two different methods for dealing with it. The most common one first. I'm going to say, fine, you want h of 1/3. Okay, we'll just substitute 1/3 in wherever I see x. Okay, which makes this kind of gross fraction looking thing here. No problem, we can sort through this. But the order that you do certain operations matters quite a bit. Okay, remember PEMDAS. This tells you that before you do multiplication, you should do exponents. Before you do addition or subtraction, you should handle any division or multiplication, right, and so on. As I look at this, I think, okay, there's some division to do, right? I'm dividing right here, dividing by 1/3. But there's also this other stuff, and I treat this top of the fraction as if that is a parentheses. Okay, I think to myself, that parentheses has to be settled first. And if I can turn that into a single number, then it's just a simple number divided by another simple number. So let's do that top portion first as if it's a parentheses. We're going to sort that out. So 2 times 1/3, no problem, that's just 2/3. I'm still going to have divided by 1/3, and I'm going to have subtract. Well, if I say minus 3, that's a problem because I do not have common denominators. And you can't have, like if I had 2/3 of an apple minus 3 apples, it doesn't really work out. You need common denominators before you sort through what that division is going to be. So I'll use a crazy one to multiply 3 so that it gets thirds. Well, that's 3 times 3/3. Or in other words, that's going to be 9/3 if I change the number 3 into something with thirds. So I have 9/3 on the right, and now let's sort through what we get. 2 minus 9 is negative 7/3, and it's all divided by 1/3. Okay, so at least now it's just one fraction divided by another fraction, and I know how to do that. I'm just going to turn it into something with a nice old-fashioned division symbol in it. And the reason I like old-fashioned division symbols is because that lets me do keep, flip, change. Right? Keep, change, flip. However you learned it is fine. The important thing is you change division to multiplication, and you flip whatever came after the division upside down. So negative 7/3 times 3/1, the 3's cancel out, and we get negative 7 as our results. Okay, now I promised 2 ways of going after this. If you want to hang around for the second way, I think this is useful, but it is an optional way of doing things. So what you can do is, first of all, let's clear some space. Right at this stage up here, when I chose to first simplify, what I could have done instead would be to use another crazy one. And I'm going to multiply by something to get rid of these fractions within fractions. I really dislike fractions within fractions. They're complicated. So how can you make a 1/3 go away? Well, you have to multiply by 3, right? If you multiply 3 by 1/3, it crosses out, you get 1. That's nice. But you can't just multiply by 3. You have to multiply by 3 over 3. That way you're not actually changing the value of this fraction here. I don't want to change the value. I don't want to make it bigger by accident or make it smaller. So now what happens is these 3's simply get multiplied in here by the following method. I multiply the 3's by these different terms. It's like distributing multiplication over parentheses when you're doing addition. So on the top left, I've got 2. Top right, I've got minus 9. And right here, I've got 1. And that becomes negative 7 divided by 1, which is negative 7. So it turns out to be a little quicker. And sometimes this method is quicker, but you really have to get used to it first in terms of distributing your multiplication.